Today we're going to be doing scientific notation, which is a section that you should already have done. We're just going to remind you about what you should already know and expand on it a bit. We're going to start off by taking a look at what scientific notation is to remind you and how it works. Okay, so first of all, scientific notation is a useful way of writing very large numbers. If you take the number 2 million, then 2 million is the same as 2 times 1 million, okay? And 1 million I could write as 10 to the power of 6. So 2 million is the same as 2 times 10 to the power of 6. Now when I write it like this is what we call scientific notation. The way that we write scientific notation is like this. You have a number that is being multiplied by a power of 10, or 10 to the power of something, where the number that is being multiplied by the power of 10 must be something that is between 1 and 10. Okay, it can be equal to 1, but it cannot be equal to 10. It must be less than 10. And then the exponent for the power of 10 must be an integer. Now, you may have so far only seen scientific notation where the exponent was a positive number. We are now going to be going on and expanding that to scientific notation where we have exponents that are negative numbers as well. Okay, but first let's just go through a couple of examples just to remind you about scientific notation with positive exponents, just to remind you about how that works. Okay, so in this first example here, you need to write the number 70,350,000 in scientific notation. So let's go and have a look at how we would do that. So first of all, I'm going to take my number 70,350,000. Okay, now when we write a number in scientific notation, remember we have to have a number multiplied by a power of 10, and the number that we're multiplying by the power of 10 has to be something between 1 and 10. It can't be equal to 10 or more than 10. So that means that the decimal point has to be after the 7. Okay, it has to be after the first non-zero digit in your number. So the first non-zero digit in my number over here is the 7. So this is equal to 7,035, and then I don't need to write all of these extra zeros at the end of here. I can drop them because now they're after the comma. Okay, so 7,035. But now obviously 70,350,000 is not equal to 7,035. I have to multiply this by something that will make it the same as that, so that I can say that they're equal to each other, because at the moment they're not. So I'm going to multiply this by 10 to the power of something that will make this decimal point move enough places so that it'll get back over there, so it's equal to 70,350,000. So now let's see how many places did our decimal point move in the first place. It moved from here 1, 2, 3, 4, 5, 6, 7 places to get over there. Remember, if you can't see the decimal point, it means it's right at the end of the number. So in this initial number that I had over here, I couldn't see the decimal point, so it was over there. So it had to move 7 places for it to end up over here. That means if I have it sitting over here, I have to multiply by 10 to the power of 7 to get it to go back all the way over there again to make it the same as this number that I started with. So 7.035 times 10 to the power of 7 will give me 70,350,000. Okay, so that's how we write a number in scientific notation. Right, now we're going to go and do an example where we're going to do it the other way around. Here you've been given the number in scientific notation, and you need to write this in standard notation, so as a normal number. So now let's go and have a look at how we would do that. Okay, so in this one over here we have got 3.806 times 10 to the power of 14. Okay, now what this means is that the 14 is telling me that when this number was written in scientific notation, the decimal point was moved 14 places to the left. So we're going to have to move it 14 places back to the right again. And as we do that, the number is going to get bigger and bigger and bigger and bigger and bigger. Okay, so I'm going to, over here, have 3,806. And I'm going to be moving this 14 places. 1, 2, 3. So the first 3 were the 806 that I already had. So I need to add an extra 11 zeros on for the rest of those places that I still have to move the comma. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 extra places in addition to the 3. So I'm adding on 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros. So that's 3. This is still, I haven't moved the comma yet, so it's still times 10 to the power of 14, so it's still equal. But now when I write this in standard notation, I'm going to move that comma all the way to the end. So I'm going to have 3, 8, 0, 6, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So now let's check. We've got 3, 8, 0, then 6, 0, 0, then 0, 0, 0, 0, 0, 0, 0, 0, 0. So now I've got the full number over here that is the same as that. This one was written in scientific notation, and this one is not, where I moved that decimal point from here 14 places to the right. Okay, so that's what you should get for that question. So now I'm going to give you a few that you're going to be doing for yourself. Before we do that, I just want to remind you about how we write this number. So when you're writing a number in standard notation, you need to try and group your digits so that you have from where the decimal point is, it grouped in threes, just to make it easier to actually read the number and to see how many digits there are in the number. So over here, it's grouped in sets of 3, okay? So what I did is I said, because I know it's times 10 to the power of 14, I'm going to end up with 15 digits. And I divided that by 3, and that's how I knew that it was going to be 5 sets of 3. Okay. Right, so now let's go and you're going to do a few of these for yourself. In this activity, you're going to take each of these numbers, and if it's in standard notation, you need to write it in scientific notation, and if it's in scientific notation, you need to write it in standard notation. I'm going to give you 2 minutes to work on this activity. Okay, so let's go through those and see what you should have got. So for the first one, you had 8, 2, then 2, 0, 0, 0, 0, 0, 0, 0, 0. You should have got your scientific notation. Remember that the comma has to go after the 8. Okay, so over here I've got my comma after my 8, and then the 2 and the 2 2's. Then we don't need to write any of the other zeros because they're after the decimal point now. And then the number of places that it moved was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got times 10 to the power of 10. Right, then the next one you were given in scientific notation, 1.685 times 10 to the power of 8. So we're going to be moving our decimal point 8 places to the right. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So that means we're going to be adding on, if I've already got 3 digits here, I'm going to be adding on an extra 5 zeros. So you should have ended up with this over here, 1, 0, 1, 6, 8, 5, and then 5 extra zeros like that. Then the next one, you had 88050000000000. Okay, so for this one, we have to put our comma after the 8 over there. So we have 8,805. And then the number of places that our decimal point moved was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 places. So you should have had 8.805 times 10 to the power of 14. Please take note, we don't drop this 0 that's already there because it's between other digits. We don't write the zeros that are after the 5, but we do have to write zeros that are between non-zero digits. And then the last one, you had 9.005 times 10 to the power of 16. So for this one, you're going to be moving your comma 16 places to the right. And because I've already got 3 digits over here, that means that you need to add in 13 extra zeros after your 5. Okay, because 16 minus the 3 we already got is 13 extra zeros. So this is what you should have ended up with. 90050 and then 1, 2, 3, 4 sets of 3 zeros after that. Okay, so that's what you should have got for those questions. Now we're going to go on to scientific notation with very small fractions. So all of the scientific notation we've done so far has been with very big numbers. Now we're going to go on to scientific notation for very small fractions. Okay. Scientific notation is also a useful way of writing very small fractions. Okay, now if we take an example like the number 0.000002, okay, now this is the same as taking 2 and dividing it by 1,000,000. When we divide by 1,000,000, the comma would have been after the 2 over here, and we go 1, 2, 3, 4, 5, 6 places to the left over here. So 0.000002 is the same as 2 divided by 1,000,000. Now dividing by 1,000,000 is the same as multiplying by 1 over 1,000,000, which is the same as multiplying by 1 over 10 to the power of 6. Okay, now we have learned about negative exponents. So 1 over 10 to the power of 6 is the same as 10 to the power of negative 6. So if I write 0.000002 in scientific notation, the way I'm going to write it is 2 times 10 to the power of negative 6. So when you've got a negative exponent, it means that you're working with a very small fraction. Okay, it means that the comma has moved the opposite direction. So when you have a positive exponent, it means that you have a very big number. When you have a negative exponent, it means that you have a very small fraction. Okay, so now let's go and do an example where we're going to practice this. So in this example, we need to write the number 0.0000003024 in scientific notation. So let's see how many zeros we've got over here. After the comma, I've got 1, 2, 3, 4, 5, 6, 7 zeros before I get to my first non-zero digit. Okay, so let's first go and write this number down. Okay, so we're going to start off by writing our numbers. We've got our 0, comma, and then 1, 2, 3, 4, 5, 6, 7 zeros, and then 3, 0, 2, 4. So that's the number that we started with. Now we're going to go and write that in scientific notation. Now, just like with the other numbers we were doing in scientific notation, the comma needs to go after the first non-zero digit. So it's going to go after the 3 over here. So we need to have 3, 0, 2, 4 times 10 to the power of something. Now we need to know what we need to have as our exponent for that power of 10. So over here, let's see how many places did our comma move. It ended up over there. It started over here. So it went 1, 2, 3, 4, 5, 6, 7, 8 places. Okay. Now that is actually the same as the number of zeros that I started with if I include the 0 before the comma. So if you count the number of zeros, 1, 2, 3, 4, 5, 6, 7, 8 zeros is the same as the number of places that our decimal point has moved. Okay, so that is going to be 3.024 times 10 to the power of 8. But because the initial number was a very small fraction, it's not just 8, it is negative 8. So it's 3.024 times 10 to the power of negative 8. Okay, now let's have a look at our next example. We're going to be doing it the other way around, writing a number in standard notation when it's been given to us in scientific notation. So for this one over here, you've got 2.006 times 10 to the power of negative 7. Okay, so if I take this number, 2,006 times 10 to the power of negative 7. Now, just like in this one over here, the 8 over here is the same as the number of zeros that I had, including the one before the comma. The same thing is going to apply for this one over here. If it's been given to me in scientific notation, then the 7 part of my exponent over here is going to tell me how many zeros I need to have, including the one before the comma. So over here, I'm going to have 0, comma, so that's my first 0, so that's 1, 2, 3, 4, 5, 6, 7, and then I've got my 2, 0, 0, 6. Okay, so now if you check it, you'll see that our comma moved. It was originally over there. It moved 1, 2, 3, 4, 5, 6, 7 places. So that's why it is because it was a 7 over there. Now, the reason that it moved in this direction, making it into a fraction, is because it was a negative exponent. So you need to now start paying attention to when you have scientific notation. If it's given to you with a negative exponent, it means that your original number was a very, very, very small fraction. If you are given the number as a standard number and it is a very small fraction and you need to write it in scientific notation, then you need to remember to put that negative in there for your exponent. Okay, so now I'm going to give you a few that you're going to do for yourself to practice. So over here, just like in the previous activity, you've got a table with numbers that have been written in standard notation or in scientific notation, and you need to write it in the other way. Okay, so I'm going to give you 2 minutes for this one as well. Okay, so let's go through that and see what you should have got. So for the first one over here, we need to write it in scientific notation. It's been given to us in standard notation. So when you write in scientific notation, the comma needs to go after the 6. So you're going to have 6.24 times 10 to the power of. Then need to see how far or how many places has the comma moved. So it's moved 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places, which is the same as the number of zeros that you've got, including the one before the comma. And because it is a very, very small fraction, that exponent is going to be negative. So you should have 6.24 times 10 to the power of negative 11. Okay, then the next one, you were given it in scientific notation, 5.6 times 10 to the power of negative 6. Now, because it's negative 6, it means that you need to end up with a small fraction. So your comma is going to be moving to the left. Okay, so now it needs to move 6 places, which means you're going to end up with 6 zeros altogether, including the one before the comma. So you should have ended up with this 0.00000056. So that's 1, 2, 3, 4, 5, 6 zeros altogether, including the one before the comma, and then your 5 and your 6. Okay, so that's what you should have got for the second one. Then the third one over here, we've got 0.0000300084. Our comma needs to go after the first non-zero digit, which is the 3 over here. So you're going to have 3,0084. These two zeros still have to be written. You can't leave them out. Okay, so 3,0084 times 10 to the power of, and then we've got 1, 2, 3, 4, 5 places that the comma moved. And because we're starting with a very small fraction, it's going to be the power of -5. So you should end up with 3.0084 times 10 to the power of -5. And then the last one, we've got 6.0408 times 10 to the power of -8. So it's been given to you in scientific notation. You need to write it in standard notation. The -8 tells us that it's going to be, first of all, a very small fraction. So our comma is going to be moving to the left. And the 8 means that we're going to end up moving 8 places, which means we'll have 8 zeros altogether, including the one before the comma. So you should have ended up with this: 0.000000600408, where this is 1, 2, 3, 4, 5, 6, 7, 8 zeros altogether, including the one before your comma. And that's what you should have got for those examples in that activity. And that is how we work with scientific notation for very large numbers and also for very small fractions where you have scientific notation with negative exponents. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.